Welcome to the TimberTech online tutorial. TimberTech is a software meant to analyze and to design timber structures that mainly rely on timber shear walls to withstand the horizontal and the vertical design actions. The supported wall topologies are the light frame ones, with both sheet bracing and steel bracing, and those made of cross-laminated timber, also called CLT or X-lam. Starting from a three-dimensional graphical interface, TimberTech allows the user to easily define the timber structure from preloaded databases, to analyze and check it under static and seismic loads and, finally, to export the calculation report together with some drawings and the three-dimensional model in IFC format. The software, born from the research team at the University of Trento in Italy and developed by TimberTech according to European standards, is now available for the Australian building professionals as a result of a process of harmonisation with the relevant Australian standards. So, let's start from the installation procedure. Once you get the setup file, double-click on it and, if necessary, skip the false positive alert that Windows Defender may provide. Then, you can read and agree to the license terms and conditions and click on Install. Now the installation is successfully completed and you will find the software by typing TimberTech in the Windows Start menu. Just click on it and then you can create a new account. Enter your email, password and an owner name that is going to be printed in the calculation report. Finally, you can activate your account by clicking on the link that has been sent to your email address. Now we can run the software, enter the registered email and password. And here we are in the software welcome page where we can start with a new project. This is the main page of TimberTech. We can first have a look at the Draw and View tabs, that are intended for the geometrical definition of the structure, while the tabs Define and Project Properties are meant to deal with the mechanical and geometrical properties of the structural elements and with all the required settings for the analysis and the verification phase. In the toolbar you can find, from left to right, the buttons to geometrically define the structural elements, some useful drawing guides and other standard tools for the definition of the three-dimensional model. However, the most effective way to start with the geometrical definition of the structure is to import a DXF file by clicking on this tool. Just choose the 2 or 3-dimensional DXF file, define the import scale and click OK. Once the DXF is imported, we can use it as a guide for drawing the structural elements. Let's start with the simple wall tool that allows the user to draw a wall by defining its two base points. The default height is 2.8 meters and you can easily edit this parameter here, together with the coordinates of the base points of the wall. It is also possible to use the Extended Wall tool that requires the manual definition of each corner of the wall element. This tool is useful in drawing walls complex in shape. You can also use the command line to type and run each command. In order to draw a wall, for example, just type wall, the coordinates of its first point and the relative coordinates of the second point. In a similar way, we can add some columns by defining their base points. Regarding beams, we can easily draw them by defining their two end points, but we must bear in mind that their static scheme depends on how we draw them. For instance, if we want to model two simply supported beams, we will draw two separate beam elements, while, if we want to model a continuous beam on three supports, we will draw a single continuous element. Finally, we can draw the floor elements by defining their corners. And, in a similar way, we can draw the roof. Here we can see some walls that should have an inclined upper edge. It is possible to manage this by using the previously presented Extended Wall tool. Alternatively, you can simply select these walls and extend them to the roof by checking this checkbox. Once the geometrical model is complete, we can move to the View tab that allows the user to edit the three-dimensional view and to display the extruded view of the model. The extruded view, together with the Color by Property tool, can be very useful to check the geometrical and the mechanical characteristics of the structural elements that we are going to define. At this stage, the geometrical model is OK and we need to assign in detail the relevant mechanical and geometrical characteristics to each structural element in the model. So far, the software was using the default properties. Now, in the Define tab, we can edit those properties and create new ones. In the definition phase, we can take advantage of the several preloaded databases that the software provides for each of the structural elements and materials. From left to right, we can open the following databases. The Timber database includes the mechanical properties of both seasoned and unseasoned, softwood and hardwood F grades, glued laminated softwood and hardwood, LVL, MGP and A17. The Panels database includes both plywood and OSB panels that can be used as sheet bracing on framed walls. The CLT database provides all the available stratigraphies and mechanical properties of the cross-laminated timber panels. And, finally, the database of I-joist sections and floor truss sections. Then the software provides a wide database of fasteners that includes the mechanical and geometrical characteristics of smooth and threaded nail, nails for plates, staples, partially and fully threaded screws and screws for plates. The last but not the least database is the one that includes all the connections that the user can use to restrain the wall elements at their base. Both ground and upper level connections are available with all their components and the relevant characteristics. Here we can see hold-downs, timber to concrete tensile plates, double hold-downs, timber to timber tensile plates, timber to concrete angle brackets, timber to concrete shear plates, timber to timber angle brackets and timber to timber shear plates. Now, we can move on the Elements section of the toolbar where we can exploit the databases seen before in order to define in detail the structural elements in the model. Let's start with the wall elements. Here you can find some preloaded topologies that you can edit. Otherwise, you can create a new wall typology and we can start with a framed one. We can edit the name of this new wall typology, choose whether the sheet bracing is on one or on both sides of the frame and choose the material type of the timber frame. Let's suppose we want to use an MGP12, just check the size-dependent material box and move to the following tab where you can choose the timber type. Then, the software provides a range of frame thicknesses and the available sizes for the studs and the horizontal plates. It is also possible to choose the number of elements composing each internal or external stud. Finally, we can set the spacing between the stud. In the last tab, we can choose the type of panel we want to use from the preloaded databases. We can set the thickness and the width of the board. Here we can see that the software requires that this value is a multiple of the stud spacing. We can type 1200 in order to meet this provision. The last step is the definition of the panel to frame nailing. We can choose among smooth nails, threaded nails and staples. Let's keep the default one. Then we can set the spacing between the nails and the software automatically calculates the resistance and the stiffness of the fasteners. OK, now we can move on the CLT wall definition. As seen before, we can edit the name of this typology. Then we have to choose between a monolithic and a jointed typology. If we go for a monolithic wall, we can simply choose the stratigraphy from the preloaded database and it's over. If we want to define a jointed wall, we will have to specify the joint characteristics, which means the standard panel length and the screw type from the database. As you can see, the software is able to provide an alert when the selected screw is not suited to the panel thickness. Finally, the shear strength and stiffness of the fastener is provided. One more note, when you find a pencil figure next to a strength or stiffness value, it means that you can manually edit the automatically calculated value. Now we can select one or more walls of the structure and assign them the wall topologies we have just defined. Just open the Wall Typology drop-down menu and select the relevant type. Regarding floors, we can define joist floors, I-joist floors, trussed floors and CLT floors. In all cases, the definition consists of choosing a material from the databases, setting the cross-section dimensions if needed and entering a spacing between elements. In a similar way, the definition of the cross-sections of linear elements, such as beams and columns, requires the choice of the material and the cross-section dimensions. As seen before, we can assign these definitions to the model elements by using the property inspector on the right side of the screen. It's time to move to the Connections definition window. Here you can set the tensile and shear connections at the base of each wall. The first choice is between ground connections and upper-level ones. Let's consider a ground connection and let's focus on tensile connections for the moment. These connections are very important for mid-rise timber buildings since the tensile actions can be quite demanding due to the rocking of walls. We can choose between timber to concrete tensile plates and hold-downs. As usual, we can choose the hold-down type from the database and the software will calculate the stiffness of the connection and the strength values of each potential failure mode. Regarding shear connections, we can choose between these four options: angle brackets with anchors, angle brackets on base timber beam, timber to concrete shear plates, and timber to timber shear plates on base timber beam. Let's consider a shear connection made of angle brackets with anchors. Again, we can choose the angle bracket with all its components from the database. Decide whether the connections are on one or on both sides of the wall and set the spacing between them. As usual, the software provides the strength of the connection according to the potential failure modes and its overall stiffness. OK, now we can assign the just defined connection to the walls of the ground level and assign an upper level connection type to the walls at the second story. OK, we can skip the definition of the lateral restraints on beam elements to prevent them from buckling, and we can focus on the definition of the loads on the structure. Let's create a new wall load definition. We have first to distinguish between internal and external wall load in order to consider the wind action or not. Then, we can see that the software is able to calculate automatically the self-weight of the wall and we only need to set the non-structural permanent loads value. Regarding the wind action, it is possible to enter the values of both the external windward and leeward actions and those of the internal pressure and depressure. The software will combine them in order to obtain the worst combination of these values. Finally, we can have a look at the floor and roof loads definition. As for the walls, we can distinguish between internal floors and roofs in order to add or remove the wind and the snow actions from the definition. Regarding permanent loads, the definition is similar to that of the wall loads. On imposed actions, we can choose the category from two drop-down menus according to the standards provisions, and then the software will suggest the load value and the related combination factors. We can assign these loads as already seen for all the other definitions, and then we can move to the Project Properties tab. In short, here you can set all the relevant seismic parameters such as the site subsoil class, the annual probability of exceedance, the related probability factor and the hazard factor. The software will calculate the elastic seismic spectrum and, in the following tab, you will find the design spectrum calculated according to the structural ductility factor and to the structural performance factor that the software provides according to the selected structural system. And that's all for the seismic parameters. On the project information window, you can type some information on the project that the software is going to print on the calculation report, and, finally, we can open the settings window. In short, here you can find information on some factors taken from the standards and edit some options such as the inter-story drift limits, the K6 factor and the region definition for the duration of the snow load. On the following tabs, you can set the deflection limits for floors and beams, the limitations to the contribution of the rope effect to the capacity of metal fasteners and some other options for the calculation of framed walls capacity. Okay, everything is defined, we can finally validate and calculate the model. On the Validate and Calculate section, the software will check the model and, if it notices some issues, it will provide a warning. For example, if we shorten these beams and we try to validate the model, the software colors in red the whole roof section and, in particular, these three joists since they are not properly supported as you can read in the provided warning. The user has to go back to the Draw tab and provide support to those joists. Another kind of validation alert is the orange one. It can appear, for example, when a wall is too short for resisting horizontal actions and in other cases. This type of warning does not require that the user goes back to the Draw tab and edits the model, you can simply click on the Optimize button and the software will fix the issue. In this case, the too short wall has been converted into a secondary element that is not effective as a bracing element. Finally, there may be some blue warnings, like this one, that should be seen as informative alerts and, if the user agrees with the provided information, it is possible to run the analysis. The software provides both the seismic static and the seismic dynamic analysis. Let's choose the dynamic one for completeness and we can run the analysis. In a few seconds, we obtain a fully analyzed structure and the results can be displayed in the three-dimensional interface according to a color spectrum and in the bottom and in the right sides of the screen in numbers. In the toolbar, we can select whether to show the results in terms of forces, moments and stresses or in terms of checks. Moreover, we can choose which kind of element we are interested in. Right now, for example, we are displaying the axial load on the wall elements arising from the sole self-weight of the elements of the structure. We can see the range of values in the color spectrum and, if we click on a wall, we can see in detail the action value here and here. In a similar way, we can display the results of a combination of actions by selecting the combination type in the first drop-down menu and the combination number in the second one. When displaying the results of a combination of actions, we also get access to the checks section of the toolbar. Let's suppose we want to inspect the checks on the tensile connections at the base of the walls. We already notice a red dot here that means that the tensile connection check is over 100% in at least a wall in the model. The software colors in red the walls whose tensile connection strength is not sufficient. By clicking on them, we can read the action values and the overall percentage check. Moreover, in the property inspector all the percentages of each potential failure mode are provided. And while we are here, you can see all the verifications the software does on the studs of framed walls, on the sheet bracing, on the shear connections and on the tensile connections. Finally, we can choose to display the results according to the envelope of all the combinations of a single type. Let's say we want to check the envelopes of all the ULS vertical combinations. We will find all the percentage verifications of each structural element and the number of the combination that leads to this percentage. When we will obtain a green check next to envelopes, it will mean that all the elements in the structure are successfully checked. Some more notes on the checks on beams and floors. Here we can see there is some problem with the bending checks of floors. The software colors in red the floor whose check is not fulfilled, and we can find the number of the most demanding combination. Then, we can go back to the specific combination. And here we can see the bending action that leads to the most demanding check, and, moreover, we can display the static scheme of each joist of the selected floor in order to monitor it. Finally, with the deformation button, you can display the deflection of the structure under horizontal loads, while with the horizontal actions button you can inspect some detail on the horizontal actions arising from wind and earthquake. In case you performed a dynamic analysis, the following tab will allow you to see an animation of each one of the vibration modes of the structure as a result of the modal analysis of the building. And finally, let's move to the last available tab that allows you first to print the calculation report of the structure in Word format. The report is comprehensive and detailed, and you can choose which sections to print. Let's scroll some pages. Next to the report, you can find the export in DXF format of the drawings of the structure with the details of the connections as you can see here. Then, an export in IFC format is available that is a commonly used collaboration format in BIM-based projects. The last two buttons allow you to export the actions at the base of the structure for the design of the foundations and to export the bill of quantities of the whole building. Regarding the first one, you can choose whether to export the reactions as a distributed action at the base of each wall or as a concentrated action in its middle point. You can as well select which loads and combinations of actions to export. These are the results in DXF and CSV format. Regarding the bill of quantities, two versions are made available, the simple one and the detailed one that, as you can see, provides in detail all the relevant quantities in the project. This is TimberTech Buildings, enjoy it.